Hello and welcome dear students. I am Kumar, your maths lecturer. We have started with the topic differentiation. In the last lecture we have seen how to differentiate composite function. Now today we will start with the topic derivative of logarithmic function. So before starting this topic you should know some basic formulas. We know that derivative of x raised to n. Derivative of x raised to n is what? N into x raised to n minus 1. And derivative of n raised to x. What is derivative of n raised to x? Here what is the difference between these two terms? Here x is base and n is what? Power. Here n is base and x is variable, so this will be in the form of a raised to x. Here whenever you have base in variable in the base and constant in power, then always you have to apply x raised to n formula. X raised to n means base is x, term of x, sin x raised to x, sin x raised to 3, sin x raised to 5. So always whenever you have variable in the base and constant in power, then always you have to apply x raised to n formula. But if you have constant in the base and variable in power, then you have to use the formula of a raised to x. What is a raised to x? A is any constant, so n is also a constant. A raised to x is what? A raised to x into log a. And n raised to x is what? N raised to x into log n. N raised to x into log n. But if we have n raised to n or a raised to a, n raised to n is constant, this n is also constant, so constant raised to constant is constant and derivative of constant is 0. But the question is what, when we have x raised to x term, then what should be our answer? Now most of you think we can apply x raised to n formula, but here we cannot apply x raised to n because n should be constant. X is base, this is correct, but n should be constant, so you cannot apply x raised to n here. Now you can't apply even a raised to x also because a should be constant and x is not a constant. Here both are variable. So when we use logarithmic function, derivative of logarithmic function, how to take log? When you have variable raised to variable term, then you have to take log on the both the sides. Or also when you have variable raised to variable, then you have to apply log on both the sides. Also suppose you have u into v, then you can apply here u into v formula. But if you have u into w into z into say suppose m into n, these are the variable terms and you have to differentiate these terms with respect to x. Then how to differentiate these terms? So here u into v is not possible. So if you take log on both the sides, then it becomes log u, and we know that logarithmic rule, product rule. If you have multiply, then it becomes plus log u into log v plus log v plus log w plus log z plus log m plus log n and so on. So when we have to take log on both the sides, first condition is what? There should be variable raised to variable. Second condition is 2 or more variable, 3 or more variable should be in multiply and division. Because we have a rule for 2 variables in multiplication and division, but we don't have any rule for variables involving 3 or more in multiplication and division. So when to take log on both the sides, for first condition is what? There should be variable raised to variable, and second condition is what? There should be 3 or more variable in multiplication and division. So let us take an example. Suppose we have x raised to x. Here we cannot apply x raised to n, a raised to x, constant raised to constant. So the last option is what? Variable raised to variable means what? You have to take log on both the sides. So taking log on both the sides, so the answer is log y is equal to log x raised to x, and we know that exponent law in logarithm, it becomes x log x, exponent law. Here we have applied exponent law, m raised to n, so n log m, x raised to x. Now you have to differentiate with respect to x. So differentiating with respect to x, and here we are differentiating with respect to x, but it is not x. So the term which is not x other than constant is known as what? Composite function. So write down d by dx with log y, and here also you have to write d by dx x into log x. But here x into log s, we have 2 variables in product, so you have to apply product rule. What is u into v rule? U derivative of v plus v and derivative of u. Here we have applied u into v rule. U derivative of v plus v derivative of u. So answer is x, derivative of log x is 1 upon x plus log x will remain same and derivative of x is what 1. So x get cancelled. So we are left with what 1 plus log x into 1 is what log x. But see the left hand side. The left hand side is what derivative of log y. Derivative of log x is 1 upon x, but derivative of log y is 1 upon y. But this is not x. For composite function, what is composite function? If we have derivative of any function log x, derivative of log x is 1 upon x. But if we have any terms other than x, then it is known as composite function. And derivative of composite function is what 1 upon x into again derivative of x. So here instead of x we have y. So y is known as composite function. So derivative of log y is 1 upon y into derivative of y again. So dy by dx. So the final answer will be 1 upon y dy by dx, and we have to find dy by dx in differentiation. So taking y in the right hand side, 1 plus log x. But what always you have to substitute the value of y in logarithmic function. What is y here? X raised to x. So x raised to x into 1 plus log x. This we are getting from equation 1. This is the final answer of dy by dx. So when you have to take log first, when you have variable raised to variable or 3 or more variable in multiplication and division, then you have to take log on both the side, then apply logarithmic formula, exponent law, product law or division law, and then apply the rules of differentiation. Let us take some more examples. Suppose we have sin x raised to cos x. Here we have variable raised to variable. Then the last option is what? Taking log on both the sides only. Taking log or applying log on both the sides. So apply log on both the sides. So when you apply log on both the sides, then it is log sin x raised to cos x, and apply exponent law. So this is cos x into log of sin x. So we have to differentiate log y is equal to cos x into sin x. So this is in the form of u into v. So apply here product rule of differentiation, differentiating with respect to x. So the derivative of log y, we know that 1 upon y dy by dx. Now you can write directly derivative of log y is 1 upon y, again derivative of y because of composite function chain rule, and here you apply product rule. So product rule is what? U derivative of v, u derivative of v plus v derivative of u. So cos x derivative of log x, composite function we know that derivative of log x is 1 upon x, but it is not x, therefore again derivative of sin x. So you can skip one step. Derivative of sin x is what? Cos x plus log sin x, and derivative of cos x we know that minus sin x. Derivative of cos x is what? Minus sin x. For this chapter formula should be perfect, completely perfect. Cos x upon sin x what? Cot x, or cos into cos you can write directly cos square x also. Cos square x upon sin x, and here you get a minus sign common. So this is sin x into log of sin x. This is the value of what? 1 upon y dy by dx. Now shift y in the right hand side. So taking y in the right hand side, so y into this term and substitute the value of y, that is sin x raised to cos x. Let us take more example of multiplication and division. Suppose we have the terms x plus 3 raised to 3 into e raised to 2x. So let us take example of multiplication and division. Suppose we have the term y is equal to x plus 2 raised to 3 into e raised to 2x upon sin x raised to 5. Here we have 3 terms which are in multiplication or division. We can also have more than 3 terms. So here compulsory we have to take log on both the sides. So taking log on both the sides. So after taking log y, here apply product rule in form of logarithm. So for multiplication it becomes plus, and you can write, you can skip one step, that is exponent law. So it becomes 3 log x plus 2, 3 log x plus 2 into 4 into logarithm becomes plus into log e raised to 2x. Or let us solve the steps. Apply log on both the side. X plus 2 raised to 3 into e raised to 2x upon sin x raised to 5. So first to apply division rule of logarithm. For division there should be negative sign. So it is x plus 2 raised to 3 into e raised to 2x minus of log sin x raised to 5. Sin x raised to 5. Now here we have multiplication sign. So apply product law of logarithm. So it is 3 log x plus 2 plus 2x log e minus 5 log sin x. 5 log sin x. Now log e, we know that log e, the value of log e is 1. So this is 3 into log x plus 2. 3 into log x plus 2 minus log e is 1. So this is 2x minus 5 log sin x. Now these are the terms with plus or minus sign. So whenever we have plus minus sign, then directly you can apply dy by dx with all the terms. So why we have taken log here? Because we don't have any rule for division or multiplication in which the terms are more than 3 or more than 3 terms. So taking now differentiating both the sides. So on differentiation you will get derivative of log y is equal to 1 upon y dy by dx. 3 is constant, so taking constant common. Derivative of log x plus 2 minus also plus 2 derivative of x minus 5 derivative of log sin x. Derivative of log sin x. Now derivative of log x, we know that 1 upon x. But if we don't have term x that is composite function, then again you have to differentiate that term, and directly you can write this derivative of x plus 2 is what? 1 plus 0, that is 1 only, plus derivative of x is 1, derivative of log sin x is what? 1 upon sin x, and derivative of sin x is what? Cos x. Derivative of sin x is what? Cos x. So answer is 3 upon x plus 2 minus 5 cos upon sin becomes what? Cot x. And this is 1 upon y dy by dx. Take y in the right hand side and substitute the value of y. This will be our final answer. So thus we have completed the topic derivative of logarithmic function. In the next lecture we will see derivative of implicit functions. Thank you.